All right. Just a quick review. Can you guys try to do this without looking at your pink packet? Can you, and don't shout out the answer, I want you to write the answer right here. Look at these two angles, this angle X and this angle Y, and see if you can identify the name of the special angle pair that we are looking at here. Please do not shout out answers. Write them down so everybody around you has a chance to think for themselves, please. Thank you. And when you've got that written down, I encourage you to write me an equation that shows what is special about that particular type of angle. See if you can write me an equation that has X and Y in it that illustrates what's special about that type of angle. So special angle pair here, these are what? So you can shout it out now. Same side interior. Now, if you said supplementary, I'd say that's true, but you could be more specific than supplementary.
What if I said same side supplementary?
It needs to be same side interior. And if you want to abbreviate that as SS int, that works for me too. Now, what is special about same side interior angles is that they are, and I heard this just a minute ago, they are supplementary, which means they add up to 180. So if you haven't already, can you write me an equation that shows X and Y being supplementary? What does it mean if two things are supplementary? It means that they should be adding up to equal 180. So write me an equation with X and Y being supplementary. I skipped over something important. Same side interior angles are supplementary, but only when? Only when it's a transversal and the lines are parallel. So can we be convinced that they would add up to 180 in this particular picture? I would say, yeah, the lines are parallel, so they must be supplementary. Okay, I want you to look at the picture for part B. There is something wrong with this picture. There's something about this picture that's bothering me. I want you to see if you can figure out what's wrong with this picture and either talk about it with somebody sitting next to you or write me a couple words here that describe what's problematic about this picture. I'll give you a couple minutes to think about that. Something is wrong with this picture. All right, I heard some great answers, some great discussion. Does anybody want to volunteer and explain to us as a class why this picture bothers you? What do you think, Emmy? Shh, guys, please be respectful of your classmates. Thank you.
We can't be sure that it adds up to 180 because there aren't any parallel lines.
Okay, so I agree with you. We do not see any parallel lines. And you said we can't be sure that they add up to 180. Are you talking about these two angles here? Okay. So you're thinking that something's got to be wrong with these numbers? And can someone tell me what special angle pair we're looking at here? They are same side interior angles. And same side interior angles should add up to 180, but only when? Only when the lines aren't parallel. So you're saying one of these angles has to be wrong. Because if the lines aren't parallel, then they shouldn't be adding up to 180? I agree. So the problem with this is that the same side interior angles add up to 180, but the lines aren't parallel. And that doesn't match what we know about same side interior angles. Look at this picture and tell me what's wrong with this one. This is basically the same picture, but they've extended it so that the lines do cross. Do you see any issue with this triangle that's formed here? We talked about what the angles in a triangle need to add up to. What do they need to add up to? 180. So what's the problem?
Angle 1 and 2 on the bottom equal what's underneath?
So what would this have to equal? 0? There's no way that's a 0-degree angle. That doesn't even make sense. So the trouble that's going on here is these angles, the angles aren't matching what we expect to see about triangles and about parallel lines. Okay. Does anybody need any help coming up with some words to write down for those questions? I'm going to leave that part up to you. All right, let's move down to the bottom. I want you to assume in this case, unlike the last case, I want you to assume that the angles are correct this time. Okay, so typically in this class, when we see a picture, whatever the numbers on the picture say, we have to trust that that is true. Okay, we do not lie to you on pictures in this class. All right, so assuming that this is 112 degrees and this is 68 degrees, the first question is that enough to convince you that line FG and line HI are parallel? And explain. Jot down a few words there to explain your reasoning there. If you were explaining this, if this were a test item, I would be looking for some very key words. I would hope that your explanation would include the name of the angle pair that we're looking at. Anything that might be special about them, and then how that relates to the properties for that angle pair. So see if you can write me down an explanation that has some of those vocab terms. Does anybody want to be bold and share what you wrote down? I'll pretend grade it and tell you what your score would be. Let's say this was a 5-point test item. Anybody want to be brave? This is an opportunity to get some free feedback. So, and just to set expectations, if there's a mistake, we're going to be kind, we're going to be gentle about it. Okay? Nobody's going to be making fun of anybody. We're all learning here, right? So I appreciate your boldness. Lay it on me. Can you read it for me word for word?
Yes, because same side interior angles need the lines to be parallel for them to be supplementary.
Oh, I love that. So yes, because with same side interior angles, the lines need to be parallel in order for them to be supplementary. Did I get that right? That's fantastic. So that'd be a 5 out of 5 response. You hit all the important stuff. You name the angle pair. They are same side interior angles. You use supplementary, which is kind of what we're seeing here. Did anybody add these to make sure that they did add up to 180? And they do, right? So in order for them to be supplementary, the lines need to be parallel. That's awesome. That's perfect. Does anybody else want to read theirs and get some feedback? Were you able to include those 3 kind of key phrases? Same side interior angles, parallel lines, and supplementary? All right. So let's write a theorem based on this. We have a theorem already about same side interior angles. It's on our pink sheet. Why didn't I write it down though? Why did I not write it down? I'm going to fill this in right now. The theorem that we already knew about same side interior angles is if lines are parallel, then same side interior angles are supplementary. We already knew that if the lines are parallel, then that means that the angles have to be supplementary. But that's not the theorem that we just used. We could modify this. In this problem, we didn't know that the lines were parallel to begin with. We started with the fact that the angles were supplementary. So do you think you could rearrange that sentence that we just wrote down so that we're starting with the angles being supplementary and then ending with the conclusion that the lines are parallel? What do you think? Something good. But let's stick with this one. Yep. We'll get to that in a moment. Yeah, so it's basically the same thing. We just flip the if and then. So the new theorem that we've just made up is that if, so what did we start with here? We started with the fact that these are supplementary. So if same side interior angles are supplementary, comma, then what's our conclusion? What has to be true if we see same side interior angles and they add up to 180? Then the lines are parallel. Do you suppose this might work with other special angle pairs? Which of our other special angle pairs involve parallel lines? Some of them don't need parallel lines. But which other ones do involve parallel lines? I'd say 4 of them involve parallel lines. Do you have a question? No? Okay. 4 of these involve parallel lines. Do you think we could kind of do the same thing with these other ones? Let's see. Flip the page over. Let's look at this one. We got 80 degrees and 80 degrees. Those 2 angles are congruent, but they're not same side interior angles. Without looking at your pink sheet and without shouting out an answer, see if you can write down what special pair of angles we're looking at here. If you need to peek at your pink sheets, use that as a last resort, but see if you can remember without using it. What is this special angle pair called? On the count of 3, you guys ready? We're going to shout it out now. 1, 2, 3. Corresponding. Those are corresponding angles. And what I notice is that we have corresponding, let's just do COR. I don't know why I'm having trouble writing at the moment. Corresponding angles are congruent. Has anybody, there should be 2 R's in that, sorry. Has anybody been taking my advice and when you see these things pop up in your assignments, actually writing down what the angle pairs are called? Yes, has it been helping you to no, you're still having trouble remembering? Keep doing it. That repetition is going to pay off for you in the long run, okay? Keep doing it. Keep doing it. Has anybody made flashcards for these things yet? What are you guys doing to try and get these down? Or do you already know them? Do you know all of them? Okay. Luck. Oh, man. Okay. I mean, okay. There's a, sorry, this is a bit of a tangent. There's a mathematical process called the Monte Carlo process. The Monte Carlo process. So Monte Carlo is a place where there's casinos, okay? And so the idea is if I'm trying to solve a problem like x plus 5 equals 11, I don't need to do any algebra. I can just take a computer and have it start guessing answers and check and see if those answers are correct. And a computer can do it super, super fast. So like you could check like 10 million different possibilities in just a few seconds. And this is called the Monte Carlo. So there actually is like a luck-based method that is used pretty frequently in higher level math. They're like, we don't know how to solve this equation. This is way too complicated. Let's just get a computer to make guesses like 1,000,000 times a second. We'll let it run overnight and maybe it'll come up with the answer. So how does it, well, you have to have some way to check, right? So whatever the problem is, there has to be a way to check. So for this problem, it would guess a number and then it would have to do whatever that number is plus 5 and check and see, ask the question, is that equal to 11? And if it is, oh, I must have got the right answer, right? So for any given problem, if you're trying to find a solution, you gotta know how to check whether the solution's right in order to use that. That's a good question. It's just guess and check. And then there's some complicated ways about how it guesses. Like if you can tell whether you're getting closer, there's sort of like a whole hot and cold thing. You know, have you ever played the hot and cold guessing game? I guess a number and then I guess another one. You tell me whether I'm getting hotter or colder. So there's some complicated ways that you can sort of zero in on it as you kind of see if you're getting closer. Anyways, I thought that was interesting. Your strategy is luck, and that is a viable strategy at some points. Let's not rely on it in geometry, though. Not too much. Okay. we got a 1 in 6 chance, right? All right. These are corresponding angles. We can see they're congruent. So, are you convinced then? Anything about those lines? What is that? What conclusion can we make about these lines? Perfect. Let's write that down. If corresponding angles are congruent, then lines are parallel. So I see two corresponding angles. I notice that they have the same measure, which makes them congruent. I can then come to the conclusion that those lines have to be parallel. This is a geometric property that I actually used over the summer. I was working on my front porch with my dad, and we were putting in a new railing. So a porch railing has to have, they're called spindles. They're the kind of vertical bars that connect back to the porch. You guys know what I'm talking about? And there's like code on how far apart those spindles need to be. And when you install those, you want them to be parallel because like if one of them's a little bit off and you're walking up to it, like you can notice it. It looks terrible. So what we did was we used this thing called an angle gauge. Have you guys seen an angle gauge before? It's like a piece of wood, and then it's got a wing nut on it and a piece of metal, and this piece of metal can kind of move around. And so you can tighten it down. So we put the first one in, and we tighten it down, and that set this angle right here. And then we were able to just slide that angle gauge down the railing to figure out how to position each of the next ones. So because we made sure that the corresponding angles are equal, then we could be sure that the spindles ended up being parallel. So this kind of stuff comes up in construction and CAD and that kind of stuff a lot. How about this one? Can you write down what's the special angle pair for these? Now, guess and check's getting a little bit better because process of elimination. We know it's not corresponding or same side interior because we've done those two already. So we only got a couple more options. Our odds are getting better. All right, here's our last one. If. What are we looking at here? Nice. Alternate interior angles. If alternate interior angles are congruent, then the lines are parallel. Wonderful. And these are alternate interior angles because they're between the lines on opposite sides. Okay. Looking back at the diagrams in A and B, write two new theorems. We just did that. I think we're done with problem 49. Any questions there? All right. Before you start on the assignment, I would love for you to finish A and B at the bottom of the page. For A, I need you to find me values for X and Y and Z. For B, it's just X and Y. That is a wonderful question. How are we supposed to find that? What I would start doing in a problem like this is I would take any angle that I know and I would start working that angle. Like, so here I would copy that 68 here. Well, I'd do the same thing in B. So I'd take any angle that I know that I could copy. Like 68, vertical angles here have to be equal. These are parallel, so corresponding angles have to be equal. Vertical angles have to be equal. I would just copy that 68 as many different places as I could. Now in B, I don't see any angles that I can copy. Oh, I do see an angle that I can copy. This X here, that's the only one that I feel like I could copy right now. We got vertical angles there. But what we do have in B is I'll encourage you to look at the two overlapping triangles. And remember that we have a theorem about the angles inside of a triangle. So I've got this little one we're going to do. That's the last one you're going to look at. Look at the two big ones first. Okay? So I've got three angles in this big blue triangle here, 62 and 50. You should be able to figure out what this angle is here. And go ahead and write that in. And then look at this other big triangle over here. And then once you've got those two things, then you'll be able to figure out what X and Y are. Finish those up and then start on our assignment. Our next assignment is, hang on a second.